Hello, everyone. Welcome. My name is Daniel Moyer. Today, we're going to be doing energy, environmental, and ESS considerations. We're going to be talking about cold weather, hot weather, humidity, elevation. As people are trickling in, I just want to let everybody know that this course is going to be accredited by NABCEP, so we can issue some credits, continuing education credits. So at the very end of the presentation, we're going to have our emails going to pop up. Go ahead and email us, and we'll go ahead and check the attendance logs and go ahead and issue the credits accordingly. Keep in mind, please spell your name when you do email us. Spell the full name so we're sure to get the name correct on your certificates. With us today is also Nathan Heston. Good morning, Nathan.
Good morning, Daniel, and good morning/afternoon, evening to all of you around the world that are joining us for this training. Daniel and I are excited, and I'll be trying to answer some of those questions as they come in as well through the chat feature.
Yeah, thank you, Nathan, for joining us. So again, we're really quickly going to get through really quickly is, who is Energy Solutions at Briggs Stratton, market drivers, growth, some of our products. Then we're going to talk a lot about temperature considerations and why that can be an issue with not only our lithium-ion batteries, but any lithium-ion battery. Like I mentioned, humidity, vibration, and altitude we're going to talk about. We'll look at a couple case studies and what people have done to mitigate some of these extreme temperature environments. Talk about what we've done to test our batteries. And then finally, we'll invite you to maybe join our Elite IQ Installer program. So about 3 years ago now, Briggs & Stratton bought Simplify Power. Simplify Power has been around for a long time relative to the energy storage game. We've got ourselves known for making safe, reliable, simple energy storage batteries, lithium-ion batteries that have a lithium iron phosphate chemistry with a cylindrical form factor. We really see the value of being part of a larger team now. Briggs & Stratton brings a household name that when we're sitting down at the kitchen table with our homeowners and we're selling them, we're presenting them a product that if they recognize that name, they can be trusted. Furthermore, Briggs & Stratton's been around for 115 years, so we have a lot of history and we're not going anywhere. So we're here to help you, help your customers, and be here for the resource for a long time to come. One complete integrated energy solutions provider. There's a lot of market drivers, as everybody knows. I was coming into work this morning, listening to the news, and for us here on the West Coast, we had a hurricane hit our Southern California coast. I know the heat wave has just been, incredible this summer, and also the hurricane season is picking up. So really, people are looking at
this is the first hurricane, Daniel, in decades, right? We don't get hurricanes here in California, so it might highlight the climate-related disasters, part of this slide, right? We normally don't get these types of things, and we had a rainfall year, right, which is record numbers. And those caused power outages for us. We lost power due to the flooding that we had here in California. So who knows? There are lots of things driving the market, right? But these are some unprecedented things. This is also the hottest July on record, and heat waves can also cause a lot of problems for the power grid based on the high demands of use of electricity during heat waves. So
yeah, and I'm also
things going on there.
Yeah, and I'm also, keenly aware and have them in my thoughts, what's happening in Hawaii. Nathan, just the other day, I got a call from an installer out in Hawaii on the island that was affected by the fires, trying to get a solar inverter online with our batteries. So it's definitely, partly by climate change, right, and by starting to leverage these clean, distributed, renewable assets like energy storage systems, like solar. We're helping to be part of the solution, not part of the problem. But additionally, by having these distributed, reliable assets like batteries, we're also able to insulate our homes from those power outages and keep the lights on, keep the loads on in our house. So yes, ideally, we all have our home as our haven, and reliable power hasn't been what it has been. Climate-related disasters, we just talked about that. Also, the electrification of everything, the idea that a lot of our loads in our homes are going to be moved over from gas to electric is definitely going to be driving this market. Clean energy subsidies through the new IRA, you can now take a 30% tax credit on storage by itself. Historically, you've always had to pair solar photovoltaics with storage in order to leverage that 30% tax credit. You can now do just storage. There's not going to be a way to recharge that battery unless you have solar or a generator. But you can still give that person kind of that uninterruptible power system for their house. Additionally, there's now new rules where we can start to offer these storage solar systems to nonprofits, people that historically haven't paid taxes and didn't really qualify for a tax credit can now take a direct cash payment offer. So a lot of things driving. We expect the market to grow. A lot of additional, driver of this industry is people that have had solar, just bought solar in the past. Well, now they want to now add a battery to leverage their system, right? Charge those batteries up in the day, discharge the battery during time of use rates, that's when electricity is more expensive during certain times of the day, usually in the evening when there's not a lot of sun out. And we can program our energy storage systems to discharge themselves to cover those expensive times. So a lot of people are looking for backup. A lot of people are looking to save, add additional savings to what their solar system is already providing. So we really see this attachment rate, the attachment rate of people adding storage to batteries going up. We all know the advantages, right? You get backup power, right? What is it worth it to your homeowner to keep the lights on, to keep the fridge running, to keep some of those internet routers and modems up and running? You can save money on your utility bill, right, by doing time of use arbitrage. Or even here in California, we've had some new laws when it comes to our net metering agreements where you're not getting that same one-to-one credit for every unit of electricity you export. It's not worth the same as every unit of electricity you import. So we can save the clean solar energy that we produce during the day in a battery and then discharge it overnight. Really off-grid, that's kind of where I came from in my history of solar, working for Sunfrost refrigerators up here in Northern California. Off-grid is definitely not as big of part of the market as it used to be. That's where it got its start, but it's still something we recognize. Our energy storage system, our inverter, our batteries are warranted for off-grid use, unlike some of our competitors. And really, by being part of Briggs Stratton that makes generators, and we make also energy storage systems, we're able to optimize those generators to work with our energy storage systems, right? It's one tech support call, it's one warranty, it's one instruction manual that has been vetted to work together. One thing I want to really quickly mention is that we've recently redone our Power Academy. The Power Academy is this amazing learning platform that's hosted on our Briggs Stratton website. You can see the URL there. We have in-person courses, e-learning courses, Power Academy Live, which is kind of allows you to jump into a session and really have some interactive conversations with us. We also have live virtual courses. Going back to in-person, if you're an installer that would like to see one of our travel trailers, we got some travel trailers with inverters, with generators, with batteries in them, and we're traveling around the country. We'd be more than happy to maybe arrange us to bring this trailer to your site and train up your technicians. Heck, even bring in some homeowners that they can learn. Keep in mind, we do have some upcoming trainings just like this. You can find upcoming trainings on the Simplify Power website. Our next one coming up is going to be the AC-DC coupling and also a state of charge. And you can see that anytime you see that NAPCEP continuing education logo there, that's an indication that you can earn credits for those. We're almost done with the history really quick. I already mentioned this, that we as Briggs Stratton Energy Solutions has a long history of providing innovative and engineering excellence. We have a line of both energy storage systems and generators. We are truly based here in the United States. These batteries that you're seeing here at the top, they are assembled in Oxnard, California. So to have the manufacturing process here in the States, not only creates American jobs, but also gives us a high level of quality control, Q&A, and testing, as we're going to talk about in a little bit. We like to definitely tout our tech support. It's always something where if you're in the field, you're trying to get that system online, homeowners looking over your shoulder, you need to make that phone call. You want somebody to pick up the phone. It's something that we've always prided ourselves in having excellent tech support. Training as well. That's why you're here today. Thank you, everyone. And we're really committed to future technical innovations and adjusting as the market demands. We also have a large-scale commercial team. I see that coming up a lot with the Solar 30K, the Solar 60K. They need high voltage battery inputs, and we do have a high voltage battery team that's working on prepackaged systems for those larger solars. If that's something that interests you, email us at the end. Our email is going to pop up, and I'll connect you up with that team.
And if you're going to be at RE Plus, we do have some training surrounding that high voltage team. And I know that we have solutions that are coming out for that 30 and 60K, the inverters that Daniel was talking about, for larger applications. So if you're interested, come see us at our booth at RE Plus.
Yeah, thank you, Nathan. And I got a slide coming up on just that exact topic. Really excited for Las Vegas coming up. So if anybody's going, we'd love to see you there. Really quickly, this is kind of the heart of our energy storage system, right? You need kind of three legs to the stool. You need a reliable battery, something that's going to be able to store energy and discharge any energy repeatedly over years. So we've recently upped our warranty. We have a 15-year warranty on this battery that you see here, the 4.98 Simplify battery. We've also offered a 15-year warranty on our Amplify battery. And when I mean 15 years, I mean 15 years. There's no cycle limit. There's no depth of discharge requirements, or there's no megawatt hour throughput or a throughput requirement. So you can really cycle these a lot. You can cycle them all the way down if you like. I'm going to say, I'd rather see you maybe keep a little bit in the tank to extend the life of the battery. But we're really excited to offer that 15-year warranty. And we're one of the few companies that's been around longer than 15 years, right? So we're around longer than what we're warranting the batteries for. Everybody always wants to focus on the inverter, which is in the middle of the screen. Of course, that's what controls the power, it distributes the power. But again, it's also the app, and that's kind of the third leg. Everybody who's using one of these energy storage systems, they no longer go out to the power shack and look at the voltage reading on their trace inverter or their battery monitor. They're looking at the app, and it's important that the app has a seamless interface, that it has the ability to do fleet monitoring. The homeowner can do kind of some adjustments, but also you as the installer able to do remote monitoring and remote reconfiguration. On the far left has been one of our workhorse batteries. That's the Phi 3.8. That one does not have closed loop communications. So be sure that you properly program your inverters, your charge controllers, as to not exceed the maximum charge or discharge ratings of that battery, and that you're not over exceeding not just the charge rate, but the voltage upper limits and lower limits. And we have integration guides on our website that tell you how to program those pieces of equipment, whether it's a MagnaSign, whether it's a Midnight Solar, whether it's that solar. The Amplify, Simplify batteries, the two batteries you see in the middle, do have closed loop communications. Those are the batteries that do have our new 15-year warranty. And those batteries pair perfectly with solar communications and also our inverter that you see on the right-hand side.
Daniel, to that end, these batteries with the closed loop communications, I would like to highlight that we've got a Cadillac of a BMS that's inside those batteries. So a lot of features to that BMS. It's really overbuilt, but well done. And that BMS is designed and built here in the US by us, right? So that's our own BMS, and it's a really high quality BMS. So you're really getting the top of the line with those communicating batteries, and there's a lot of features to them. That being said, there's still a lot of people that like those simpler Phi batteries, and you get a better, you get a lower cost point coming in with some of those Phis. So if you don't need all those kind of more complicated closed loop communications, you don't need to use them. And we have some trainings coming up on the Phi battery as well, and how well it features with off-grid systems. So
that's exactly right. It's not like that Phi battery is anything less than those other batteries. It's that if you have an older system, maybe you're replacing out some lead acid batteries, go ahead and leverage that Phi battery, because the existing equipment, that old MagnaSign or that old trace inverter, can't communicate, so why buy something that you really can't leverage? Great point. And Nathan, I was really pleased to see you had done a training last week on the whole hour was just on battery management systems. If anybody wants to rewatch that, you can check it out on our YouTube channel, Briggs Stratton Energy Solutions, where Nathan did a great job of diving deep into what a battery management system does. You know, it's mainly there for cell balancing, but it does so much more. Thank you, Nathan, for those comments. One quickly I want to mention is that if anybody out here is doing generators, we have a complete line of standby generators. These are standby generators, right? So they're running off of propane or natural gas. And we even go up to the commercial size. You can see some of our automatic transfer switches down there in the bottom right corner. So as Nathan mentioned, we would love to see anybody who's going to be at RE Plus this year. We're going to be at booth 5554. And if you're walking the show floor, if you happen to see the storage central theater, or maybe you start to see some Carhartt clothes, you're close, come by, say hello to Nathan and I. We'll be there doing some in-booth trainings. We're going to be talking about really energy sales, how to position this stuff when you're sitting down at the kitchen table, commercial, industrial, like Nathan said, talking about the solar, larger solar systems, and even much larger systems as that. We're going to be joined by one of the head trainers, Dylan from Solarc. Really excited to also be talking about off-grid systems and how we can leverage lithium-ion batteries. Additionally, Sequoia Cross, who's one of our vice presidents, is going to be doing a training on the value proposition of software. And that's how I mentioned a little bit earlier, is how these apps really matter. And that's how a lot of people interact with our systems. So let's get into temperature. I really want to kind of quickly walk through, you know, what's happening in a lithium ion cell, right? And we use lithium iron phosphate. So what we're looking at here is in the middle is kind of a cutaway, the kind of the spooling of a cell, and you see these different layers. Lithium really likes to live in that metal oxide layer, right? The lithium ions want to stay kind of to the left-hand side of that battery. And what we're doing is when we charge up a battery is we're kind of using a charger to kind of force the lithium over to the graphite side. And you can see that there's a porous separator layer there that really allows the lithium ions to migrate, but not the electrons. So what we have to do is pump the electrons using a charger over to the right-hand side. And as the electrons are pumped over to the right-hand side, the lithium is kind of integrating into that graphite layer, and that's a fully charged battery. As we start to get colder temperatures, a few things can happen. One is that the lithium ions don't like to move as fast, and also that porous separator layer, or the organic electric solvent, the solution that's in throughout this whole battery, becomes much more viscous. And it really starts to become like you would imagine molasses become much more viscous, which really kind of slows down the migration of those lithium ions. So what we want to be careful of is that we don't force the battery to be charged too quickly when it's cold, or we can damage the battery. Nathan, do you want to add anything to that?
Well, I think you did a great job in the overview there, right? And so as we pump those electrons over to the right-hand side of the screen, the lithium follows them and migrates through that organic electrolyte, as Daniel was talking about. And one of the things that can happen in really cold weather is, because you have that low mobility, there's also a slowdown of getting the lithium into the graphite layer there. And what you can result in, and this is true for all lithium battery cells right now, until solid state cells come out, right, is that the lithium can build up on the outside of the graphite and it can't work its way in. The process of getting between the layers is called intercalation. And in really cold environments, you can get solid lithium deposits forming on the outside of the graphite. Daniel, remember what those are called?
Dendrites?
Yeah, the dendrites. And that growth, that means branch chains or chains. And so you can imagine them growing almost like tree branches across from the graphite towards the metal oxide cathode. That can damage the battery. And so point being, we have to pay attention to temperature when we're dealing with lithium batteries. This is true for all lithium cells. Even though we're using cylindrical cells, the best geometry that's out there, the most durable and long lasting, it's still true there. So we have to pay attention to temperature, and that's what Daniel's going to be getting into.
And additionally, that cylindrical cell is more expensive than some of these other form factors. which really creates this higher upfront price. But if you start to look at the longevity or the cycle life of the battery, and you start to look at the lifetime cost of the battery, not just the upfront price, we truly believe that the cylindrical form factor with this lithium iron phosphate chemistry is the advantage. I think that's your iPhone battery there in the left. You can see Nathan holding a pouch cell that's swollen up. So yes, thank you for that, Nathan. And let's exactly jump into that. Nathan, I'm going to break down this this chart for everybody, and then I'd love to, maybe you can chime in and tell us about that tech support email you had the other day. So what we're looking at here is on the left-hand side, we're looking at the voltage of a cell, right? Imagine those little cylindrical cells that I just mentioned. Now we put these cells in series, right? 16 in series. So if you have 3 times 16, that's 48 volts. So as we're looking on this left-hand side, imagine 3 volts is kind of 48 volts. Down on the bottom, we have depth of discharge, just so, and it's not state of charge, it's depth of discharge. So on the far left is a fully charged battery, and on the far right is a fully discharged battery. And these different colored lines represent the discharge curve, right? We're discharging the battery at a C/2 discharge rate. And you can see that as the battery cells become much colder, the state of charge of the battery at a given voltage differs. So you can see here, for example, that a cold battery at a 20% depth of discharge might be at, say, 25% state of charge is at 48 volts, while a much warmer battery might be at the same discharge rate, might be at a much higher voltage, but still show that same depth of discharge. So go ahead, Nathan, explain what we had talked about.
Yeah, so I just want to point out to everybody, we're going to go through this kind of quickly, but it is quite relevant here. So this is a discharge curve. So these are batteries that are being discharged at a high rate. A C/2 rate means the full battery would go to 0% state of charge over the course of 2 hours, right? So we're discharging them quickly. And so as Daniel mentioned earlier in the talk, the electrolyte, the organic electrolyte becomes much more viscous in cold temperatures. And so what you're looking at here is a single cell, but as Daniel's noted at the bottom of the screen, we have 16 of these cells in series to produce a full battery, or stacks of these cells to produce a full battery. So that's why the voltages are only 3, they're 16 times less than a 48 volt battery. But what's happening here as we discharge in cold temperatures, there's a lot of internal resistance. And so that internal resistance creates a voltage drop, right? Now, as that battery is discharging, you'll hit a lower voltage, right, at a higher depth of discharge, right? And so that if you're discharging down to the same voltage at each time, right, and you're in cold temperatures, you're going to have a lot of energy left in your battery when you hit that same voltage. So Daniel, you asked me to talk about one of our friends who attends these trainings sent in a question, and he was asking, hey, look, in December, I was discharging my battery down to, I think, 51.5 volts, right? And I noticed it charged back up in only 2 hours. I'm using a generator to charge it back up. I'm off grid, right? So then now in summer, I'm discharging to the same 51.5 volts, right? But it's taken 4 hours to charge back up. Why is that the case? And the answer is that the voltage, right, of that battery bank is not a great indicator of the amount of energy left in the battery, or what we say the state of charge of the battery, right? So in the wintertime, when he's discharging down to 51.5 volts, you hit that lower voltage at a higher state of charge. So you might hit that voltage with 70% of the energy left in the battery. And so it only takes a couple hours to charge it up. If you're discharging in warmer temperatures in the summer, you might have discharged all the way down to 30% of the energy remaining. And so in warm temperatures, it takes a lot longer to charge back up because you pulled a lot more energy out of the battery, right? And so just keep this in mind as you go. There are seasonal variations that have to do with the temperature, and temperature has a very big effect on the voltage of a battery under discharge. Now, at the very top of this graph, what you can see is the resting voltages. Temperature has almost no effect on the resting voltage of the battery. So resting voltage of the battery is a very good indicator of what the percentage state of charge is remaining in the battery, but that's only when you're not in a charging cycle or not in a discharging cycle. So keep that in mind as we're trying to think about how much energy is left in the battery. If you just stopped the system from discharging and looked at the resting voltage, you could look at one of our charts and say, oh, look, I've got 52% left in our battery. Now, some inverters are better than others at estimating how much energy is left in your battery, right? They'll say, oh, it's it's at a 30% state of charge, and you trust that number. But some, older equipment especially is worse at kind of seeing how much energy remains in the batteries. And so if you have questions about that, you can call into tech support. But we wanted to highlight to you that temperature does play a role. And in cold temperatures, you typically hit these cutoff points earlier.
Thank you, Nathan.
Yeah, and the other point to make, and I'm going to try to go really quickly here, is that when you are charging and discharging batteries, they typically heat themselves up and get to warmer temperatures when they're cycling. But in really cold environmental temperatures, if the interior of the battery is cold, right, this will play a bigger role in when that inverter kicks on and kicks off, if the decision to run a charging cycle is based only on voltage.
Yeah, and that's another reason why we like to always push our communicating batteries with equipment that can listen and talk to a communicating battery, because we're able to transmit more accurate voltages and also use a shunt, right? Measure amps in and amps out and really transmit a more accurate state of charge to pieces of equipment. Thank you, Nathan. As part of having that communication capabilities, what we can do is, as the battery gets warmer or colder, we can send commands to that piece of equipment to adjust that charge rate. So as you're seeing up on the top is our non-communicating 5 battery. And we need to be careful that if you're going to be using this battery, that you use it in kind of a more narrow temperature windows. And that way is because really the battery doesn't have the ability to talk to the inverter, to talk to the charge controller, and tell that piece of equipment to slow down my charge rate until I can warm myself up. So you can see up here that if you're really looking for a cold weather application and you have an ability to leverage a piece of equipment that can talk or listen to the battery, such as a Solarc or a new inverter, go ahead and leverage the amplified battery. When you're communicating with that amplified battery, what we do is really adjust that charge rate. And you can see that the charge rate on the right. So we're requesting that the piece of equipment adjust the charge amp rates accordingly, as what you can see there. There are eventually going to hit some limits where the battery is going to tell that inverter, tell that charge controller that we've gone too cold or we've gone too hot. Let's go ahead and stop until we've gone back into a nominal situation.
Hey, Daniel, somebody was asking earlier, and you and I are so used to these numbers, we are throwing out words like cold temperature. And so they asked us to define what we mean by cold temperature, and it's kind of on the screen for you here now. And so I thought this would be a good time for you to talk about, what is cold, right? And so you can see on the screen there for a communicating battery, once we get down below about 10 degrees Celsius, right, we're looking at, slightly above freezing, we start to slow down the charging rate and discharging rate a little bit to protect the battery. So when we say cold, we're talking about the temperature of freezing water, 0 Celsius or 32 Fahrenheit and below. And so what we can do with these batteries, a lot of companies will just turn the battery off. So the temperature protection on cheaper batteries that don't have this advanced BMS that we have, basically just stops the battery from doing anything when you hit 0. And what we can do with this BMS is that our programming allows us to actually slowly charge the battery all the way down at negative 20 degrees Celsius, right? That's very, very cold, right? Negative 4 degrees Fahrenheit. We can still charge this battery slowly. So that's the temperature range that you were asking about. When we say cold, that's what we mean. Most companies just have their batteries shut off at 32 Fahrenheit. Ours will keep going all the way down to negative 4 Fahrenheit, right? Way below that. And it slowly, as we slowly let that charge into the battery, it warms the battery cell up. And as that battery cell gets warmer, we can start to increase the charging rate, which continues to increase the battery temperature. And so we have a much broader range than other companies here. This is a very innovative way for us to allow cold weather charging. We also have other solutions that Daniel's going to get into, but that's the temperature range. And thank you for that good question. And I'm sorry we didn't define what we mean by cold temperature. But there it is on the screen.
Yeah, thank you, Nathan. Yeah, and we should also mention by cold temperature, we mean what temperature. We're measuring the internal temperature of the batteries. And we'll talk a little bit about this in a minute, but there is a difference between what you might expect to see the internal temperature of the battery versus ambient temperature. And in these Phi and amplified battery, or the amplify and simplified batteries, those thermistors, right, the device that's measuring the temperature are embedded inside the cell pack. They're embedded on the battery management system. So it's accurately measuring the internal temperature of the battery when it's generating its own self-heat due to the internal resistance of the batteries. I get this question a lot. It's like, how long can I let the battery sit in my off-grid cabin during winter? And the question is quite long. You can really see on here, down to 10 degrees centigrade, up to 25 degrees centigrade for that long 6-month period. And a little bit colder, kind of a lot bit colder, really, when we're talking about a 3-month period. So the concept here is that if you are going to have some batteries sitting there in a cabin and you're not discharging them and you're not charging them, more importantly, you can go ahead and have them sitting there and they're going to be safe when you come back to the cabin in springtime. Make sure that we get a full charge cycle on those batteries. One thing we're also not mentioning here is that these batteries have a very low self-discharge rate. So they really hold their charge, usually about 1% per month. So, but again, I want to see everybody put these batteries on a full charge cycle before you start to turn on some loads. So maybe show up a day early before the family gets there. Keep in mind that the Phi battery, like we mentioned, does not have an internal temperature monitoring system that can communicate to an external piece of equipment. So it's really important that we adjust the programming on different inverters and charge controllers so that we're setting them up. And some inverters do have that temperature compensation. However, the Amplify does, and like Nathan had mentioned, we can use an innovative solution, right? We can slowly warm up the battery by telling the piece of equipment what our internal temperature is and what the corresponding charge rate should be.
Hey, Daniel.
Yeah.
Tim Olson asked a good question here. Would you recommend battery heaters even at 50 Fahrenheit? So ambient temperature 50 Fahrenheit. I think the way I would answer this is no, right? What you just said, Daniel, the batteries under use are going to heat themselves. And so, we're really talking about when the ambient temperature is freezing or below. The internal battery temperature, let's suppose the ambient temperature is maybe 30 Fahrenheit. The internal battery temperature is going to be above that at close to 40. And that's really when you start to have to worry about throttling, or if you don't have our advanced BMS, having temperature protection built in. And so we're talking about temperatures 30 and below ambient, and internal battery temperature will be a bit warmer than that. And as that battery is used, the temperature of that battery can kind of self-regulate, right? The battery warms itself up.
Yeah, and really, this hasn't been that, it has always been a concern in the industry, but what we're seeing now is the adoption of these energy storage systems across the country and a lot of northern states. I'm thinking like the Michigans, the Montanas, the areas, the East Coast, New England, where you really are seeing a lot of colder temperatures. Didn't matter much when we were all in California, but now that we're seeing it peripherate around the country, these temperature considerations become more important. What also matters is keeping the rain out of your batteries. Our Phi batteries and the Amplify batteries, which are the ones you're kind of seeing in these cabinets, are not outdoor rated. That simplified battery, the kind of larger square battery, is outdoor rated. So if you are going to be using some of our Phi or Amplify batteries, we have these great cabinets. These are our Boss 12 and Boss 6 cabinets that you see on the left-hand side. And we can even take one of our Boss 12 cabinets and put an inverter up on top and put 6 batteries down on the bottom and give you this outdoor NEMA 3R rated enclosure. And we're going to talk about here in a second, there's ways to maybe insulate this cabinet. And if you think about that solar sitting up there at the top of the cabinet, that's generating heat. So there's, again, that kind of idea that not only the batteries could be generating heat, but other balance of systems, other parts and pieces inside of an enclosure could be generating heat and keeping those batteries a little bit warmer of a state. You're seeing some of our bus bars here, and then also terminal blocks as well. So really,
we talk a lot about cold temperature. Could you go back one slide?
Yeah.
I think another point is that same consideration that if you put an inverter inside a battery cabinet, heat in a hot temperature environment could be a problem, right? And so if you're especially in an indoor install, and actually these solar arcs are outdoor rated, if you're in a hot location, you might want to have that inverter outside of those battery cabinets, right? So keep that in mind, right? You know, many people are asking us questions about cold weather. We sell a lot of stuff in North America, so a lot of stuff in Canada. But on the hot side of things too, you also have to be aware of the heat, and we want to make sure that we don't overheat the cabinets. Now, these cabinets Daniel is showing are NEMA 3R rated, which means rainproof, but they also have built-in fans that you can see there, and that helps to cool your batteries down as well. And those fans only turn on and turn off when the cabinet is too hot. So they're temperature-regulated fans inside these cabinets.
Yeah, that's a great point. You know, like I said, sometimes that heat generated by the inverter can be a benefit, and sometimes it can be a hindrance. And ideally, you know, these are outdoor rated, but you know, don't always try to put them on the south-facing sun on side of a house. Really, one of the kind of the gist of this slide is when you're looking at that picture on the right-hand side, and you're thinking about that cabin, that little shack that they built. Well, that shack is not only insulated, but it's also, you know, there's the three kind of conduction, convection, or radiation, and there's different ways that you can lose heat. And one of the ways is if you have a big metal cabinet sitting out under a nighttime sky, you're going to radiate a lot of heat out of that cabinet. So there's other ways to keep kind of the batteries warm. And what I want people to kind of keep in mind looking at this slide is that just because of your outdoor ambient temperature may be at one temperature doesn't mean that the interior temperature of this power shack or even the interior temperature of the battery is going to be the same as ambient. And you can really see these solar modules are really kicked up. So this must be a very, very high latitude location where they're really trying to capture some of that winter sun as it's kind of skirting across the horizon. If you do expose one of these batteries to these freezing temperatures, you can permanently damage it. You're going to get a loss of capacity and really a reduction in its cycle life, potentially just voiding its warranty. So keep in mind these considerations. We already talked a little bit about this, but I just want to kind of reiterate it that, you know, the battery management system in that Amplify can reduce its charge rate based on the temperature it sees internally. And it needs to be working with a compatible inverter to make sure that works and provide that warranted protection. Insulating, we can insulate some of these cabinets. What you're seeing is that kind of on the right-hand side is that rolled kind of rubber kind of insulation. And then additionally, there's some of the foam board. So when I mentioned earlier, you have a big metal cabinet, and you put a bunch of batteries in it, the last thing you want to do maybe necessarily is have a battery that's in direct contact with a cold metal shelf. And then we can lose a lot of heat through conduction on that metal shelf. So what can we do? We can get some pieces of insulation that are rigid enough to support the weight of the batteries and go ahead and insulate that and slow down those heat losses, whether it be through those three different types. Keep in mind, again, already mentioned this, that there's the ability for heat to be generated inside those cabinets. And potentially, you could cover some of those vent holes to kind of trap some of the heats in, but I'm a little cautious on recommending that because when summertime comes, I want to see that those vents are opened up and are allowed to vent out hot air. There are heating pads. So let's talk about if we did have an extreme cold temperature, or maybe we're using those Phi batteries that don't have the ability to talk to a piece of equipment and use its own internal resistance to warm it up. We can get some heating pads. And these heating pads are placed underneath the batteries, ideally on top of a piece of insulation. So you're not spending a lot of energy heating the cabinet, but you're kind of focusing that heat going into the batteries. The heating pads need to be special ordered. And what we do is we install thermistors inside the battery case itself. And these are different than the thermistors that are already installed on the Amplify batteries. These would be on the Phi batteries, and we can use the energy essentially from the batteries to heat themselves. So when we are sizing these systems, we need to be careful. Now, Nathan, we always get this every kind of talk we do this. How many watts does one of these heating pads consume?
Great question, Daniel.
About 45 watts.
Yep. Yeah.
But it's important to note that it's like your refrigerator. Maybe it cycles on and off. So don't just assume that it's going to be kicking at 45 watts 24/7. It's going to be cycling on and off as the temperature kind of hits those different offsets in the thermostat.
Yeah,
so
I think that's a good point, Daniel. I do want to interrupt you here. We've got so many great questions coming in, and keep them coming, everybody. I just haven't been able to keep up by typing here. But the first one is the dendrite growing at cold ambient conditions? Is this an irreversible state? And the answer is yes. And then we had another question that comes in that said, below 32 Fahrenheit, is there a point of damage or just poor performance? So those two questions are related, and I wanted to answer them. So dendrite formation is an irreversible thing. It's basically the solid lithium deposits that I was talking about. That's what we mean. And it takes a long time for this to accumulate, right? And it also depends on how quickly you're charging at low temperatures. So if you're charging at below freezing at very high rates for years on end, right, this will first present itself as a loss of capacity. So your 3.8 kilowatt hour battery, you know, if you charge this below freezing at fast rates for several years, you might see that battery capacity drop to 3.5. And then the next year, it might drop to 3.4. And what's happening is you're actually losing lithium ions out of your battery. They're not there anymore because they've solidly deposited, right? If you continue to do this over many, years, what ends up happening is those chains can actually grow long enough that they could short individual cells out. They could puncture the solid electrolyte interface, that is the separator layer, and actually connect the cathode to the anode. Now that's very uncommon. Mostly you're just going to see a loss of capacity if you're continually charging at high rates at low temperatures. So these heating pads that Daniel has are a good solution, but most people will just keep the batteries inside. And even if they're in a garage, if they're on an interior facing wall, so that you have three of the walls to your garage, your exterior facing, and typically you have one that mounts to the inside of your house. Use that wall. And so the answer is yes, it's irreversible. So try to avoid this. And there are ways you can avoid it. One, you can use the battery cabinets. Two, you can use these wired in heaters that are here. But it also, charging quickly at low temperature once or twice, this takes hundreds of cycles. These batteries can last for 25 plus years if treated nicely, right? So it's not like a single cycle is going to ruin the battery, but you want to pay attention to not do this regularly. And Daniel's, giving you options for ways to do this. Additionally, that Amplify battery, if you've got a communicating equipment that's able to be controlled by the signals coming out of the Amplify battery, like the SolarArc or like our inverter, it will adjust the charging rate automatically for you, so you won't need to do that. So great questions coming in. Keep them coming. I'll try to keep up a little bit better. So thanks, Daniel.
Yeah, and we're going to get through this, and we'll make sure we leave some time at the end to address all these questions. That's what makes these talks great, is this interaction and the questions coming in. There are of course, other devices. Victron makes one, for example, that it has its own temperature sensor. So you can take that thermistor that you see on the far right there and perhaps sandwich it between two batteries. So although we're not having a thermistor embedded inside the battery, kind of sandwiching them between two batteries is going to get us close, a little bit closer to reading internal battery temperature and not ambient temperatures. And then based on the signals being sent from that thermistor, this charge controller from Victron can adjust its charge rate so that it's not charging the battery too quickly at a cold rate. Additionally, this Victron battery management battery monitor, the BMV 712, it can also has a shunt, so it can measure amps in and amps out, and then gives you a much more accurate state of charge reading versus just basing the stated charge of the battery solely on its voltage. And as Nathan kind of explained to us all earlier, that can be very confusing when we're not at a resting voltage and we're at a discharging or a charging rate, and the stated charge isn't necessarily the same at different temperatures for the same voltage. Hot temperatures as well. Really, this is going to be related to some of the places in the Southwest. And just as we see kind of the proliferation of energy storage systems to cold climates, we're going to see them in warmer climates as well, especially as these heat-related climate change events happens. So again, it's important to note that the internal temperature may not be the same as the external temperature. And there's ways to keep these systems cool. I know in the large high voltage solutions, they actually use mini splits or heat pumps to actively keep the cabinets at a given temperature. I'm right on the Pacific coast. I'm in Arcata, California, which isn't too far from the coast. And I know Nathan's pretty close. So when we think about humidity, right, we're thinking about atmospheric moisture. And that necessarily doesn't really present a threat. What really presents a threat is when we have salt in the air, and these batteries, they're not hermetically sealed, right? So there is a possibility that over years, over time, that humidity and salt can work its way into these batteries and start to cause rust and really corrosion inside these batteries, which can create problems. So if you are in one of these situations, let's keep them inside. Let's keep them as protected as possible, and keep in mind how that can affect it. Altitude as well. This has been a big kind of issue mainly with other form factors. What I mean by that is we use the cylindrical cell form factor, right? So not only are we using a safer chemistry, the lithium iron phosphate battery chemistry, but we're also using a cylindrical cell, right? We pointed it out earlier, that kind of AA or AAA looking cell. Well, as you can imagine, a cylinder, right, just like a propane tank, has a lot of inherent strength to it. So cylindrical cells have less problems at higher altitudes than, say, a pouch cell or prismatic cell that doesn't have that hard, rigid kind of form factor and casing. So one thing to keep in mind is not only can be an altitude limit on the batteries, but also the other pieces of equipment can have altitude limitations. For example, our inverter has to be at 4,000 meters or less. Really, as somebody who lives on the Pacific coast, I've seen a lot of RVs and Sprinter vans and van conversions and Airstreams coming up and down the West Coast. And I'm always kind of blown away by how sophisticated a lot of these off-grid kind of energy storage systems can be in some of these pieces of equipment. We definitely have seen a lot of success, people using our batteries in these applications. Keep in mind that, ideally you want to maybe use some of that soft foam insulation to kind of dampen some of the vibrations that some of the battery may see. Don't put the batteries directly under the axles of the trailer, put it in another location where the batteries aren't going to see as much vibrations. But we've seen a lot of success in this, and they work great in that applications. So we're going to show you a couple of pictures of what people have done. Some of these are kind of more homebrew than others, but I think it really illustrates kind of the creativity. And this is an off-grid cabin in Montana. On the picture on the right, you can see that grizzly bear. It's cold here, right? You can see that ground mount array, and they're using some Schneider equipment. What did they do? Well, they built this insulated battery cabinet, and you can see this rigid foam board here. You can see what they've done, and I really like this technique, is we definitely have bus bars for our batteries, but what we want to see is that when you are wiring up our batteries, they have to be all in parallel, right? They're 48-volt batteries, or if you buy the 24-volt versions, don't wire them in series for 48 volts. Buy the 48 volts. And when you do wire them in parallel, use conductors of the same gauge and the same length going to one common terminal block, which you can see as this combiner up here. So they have 6 of our batteries. These are a little bit of the older cases here, the black cases. Our newer ones are powder-coated metal. And they just got a ton of insulation in there. And they were really able to make this work without any warming pads. And really, you can see this nice, large insulated cabinet. So again, insulation can really be a driving factor to keeping these things warm. This was a great system here where they're using these amplify batteries, and we're talking to our Solarc here, and you can see in this cabinet that there is this, it's kind of a little bit hard to see, but it is insulated. And down here on the right, what is that? It's a heater, right? It's a thermostatically controlled heater that can keep this room warm. What you're seeing also are some of our wall brackets that are allowed to, so if you don't want to use one of those Boss cabinets, or you don't want to build that little kind of foam box that the previous person did, use some of our wall brackets. These are optional wall brackets, and you can see they've wired all of the batteries in parallel using these terminal blocks that you see here in the center. So a great system. And I believe this is a gas heater. You can see it's not an electric heater. You can see a little yellow gas line coming in here and running up to this heater. A food truck, like I mentioned, mobile applications is always something that's very popular. I really liked about this is that they've kind of created these metal kind of strap to keep not only the batteries from shifting horizontally, but also shifting vertically. It looks like they're using some outback charge controller, an outback inverter with a midnight solar charge controller there. And they've got this kind of creative way to put solar on the top of these trucks where it can kind of slide out and give them some extra PV arrays. Definitely hot weather. We talked about this already. This is an oil drilling rig out in Arizona, and you can see this container here has been insulated with that rigid foam board. We've got a bunch of midnight solar combiners. We got some Outback, looks like Radian inverters here, midnight solar charge controllers, or those could be Outbacks, and then a whole bunch of our batteries kind of all in parallel down at the bottom. One thing I want to mention is that we do testing, because we have a manufacturing facility here in Oxnard, California, we also have an R&D facility right next door that allows us to bring our batteries into a lab and kind of subject these batteries to some real world environments that allows us to vet these batteries before we ship them out to you to put in your customers' homes. Additionally, we do have third-party testing. One of the third-party testings that we had to get through is this UN 38.3. This basically allows us to airship our batteries. And one of the tests that they do is they essentially simulate what a battery might expect to see in a cargo hold of an airplane, right? And what might you expect to see in a cargo hold of an airplane? Well, pressure changes as the plane goes up in the air and comes back down. So they cycle pressure changes, temperature changes as we're going up in the air and coming back down, vibration, and shock, right? So in order to pass these tests, we send a battery out to one of these labs, and we can't have any leakage, venting, or rupture or fire. And we were able to provide that. Additionally, they short circuit the battery to make sure really it doesn't exceed a certain temperature, and then they overcharge the battery to make sure that it doesn't catch fire. So everybody will get a copy of this slide deck, and they can go ahead and click on some of these resources to dive a little bit deeper. Another thing that we have to pass is the UL listing for our batteries. And UL has a few different kind of tiers. We all start at UL 1642, where we send our individual cells into a UL lab, and they subject the cell, remember the little AA or AAA cell, to a lot of these abnormal kind of conditions, both electrically, mechanically, environmentally. Then they take the same cells and combine them into a battery module or a battery, and then subject them again to those same kind of hazardous conditions. And we were able to pass both of those UL listings. Then what we did is finally took those battery modules or batteries and put them into a battery system, right? And the system uses a listed inverter, a 1741 inverter, and our 1973 batteries, puts them into a system. And then what we have to do is pass our UL 9540A. And the UL 9540A is not a pass fail. It's not a certificate. What it is, it's a test that subjects our batteries to kind of intense heating where they wrap some of these battery cells in heating wraps, heat them to such a point that they go into a thermal runaway event, where thermal runaway is roughly defined as once we've heated it to a point that the battery has enough energy being released from it, that it has enough heat being released from it, that it then causes adjacent batteries to go into their own thermal runaway and kind of cascade into this uncontrolled, unmitigated thermal runaway. What we did, and kind of, I'm not going to explain this whole chart on the right, but really what it showed with our batteries is that it self-extinguished, and we didn't get that kind of unmitigated thermal runaway. And these 9548 tests are really important for the industry as these energy storage systems are becoming more commonplace, right? It's important that the first responders, the firefighters that are showing up to these potentially hazardous energy storage system fires, understand what might be expected. So a lot of jurisdictions around the country won't let you pull a permit to install equipment that unless it has this 9548 test. Terminal blocks, I already mentioned this before. The reason I kind of wanted to show this is that we had bus bars before. I've already showed you a couple pictures of terminal blocks. This is a really nice clean installation where you can see that these conductors are a little bit longer here to account for this conductor here. And you can see also that they've insulated this battery cabinet to kind of retain the heat inside this cabinet. Lastly, as we're finishing off the hour, I want to invite everybody to be part of our Elite IQ Installer program. So if you're out there installing our batteries right now, I thank you. And I'd love to put you on our maps. We can get you some cash back. We can highlight your company in one of our newsletters. And then also we have a $25 cashback program. And if somebody's looking in your area to install, we'll send them your way. So wrapping it all back up, please be sure to check out the Power Academy. Anybody can sign up for that and start doing some in-person e-learning, do some of those Q&A sessions, or even one of these live virtual classes. Keep an eye out for some of our upcoming trainings. We're going to be talking about some ESS design considerations and some battery chemistry.
So Daniel, good point there. I just want to talk about, it was one of those sessions, one of those live trainings. I'll be in Columbus, Ohio next week. And so if you're interested, I think there's still a few seats open in that course. We'll be going through the ESS system and battery system. 2 days prior to that are generator trainings. So I'll be in Columbus next week doing that. I did want to point out that when Daniel was talking about that battery rebate, you know, for each battery that you install, we send you a $25 check. And so if you install 10 batteries at the end of each quarter, we're gonna send you a check for those batteries that you install. And as an elite installer with us and part of our IQ program, you're also eligible for some other promotions. We've had beta testing programs with elite installers, etc. So consider signing up for that. It's free to sign up, and you basically, after you register your warranties, just get a check from us quarterly. So take advantage of that. Daniel, we had a question come in. I know you're wrapping things up, and I wanted to get this question from Fernando answered. He said, so about high humidity, high salt areas, I'm specifying these batteries for an island, literally an island. Humidity and salt gets in everywhere. Granted, it's less bad indoors, but even indoors we have problems. So are simplified batteries a good idea or not? Can I answer that one, Daniel?
Yes, please, Nathan.
Sure. So Fernando, we have our batteries all over the Caribbean. We have, in fact, we have one of our lead sales members, right, our lead application engineers in Puerto Rico right now. We have our batteries all over Hawaii, and we've had them there for years without incident. I will say that it's important to make sure we don't get the batteries rained on. So we've had a few battery warranty cases that have come back, and there's literally been a screen door next to battery installs, and you know, salty rain can blow sideways through screen doors. So just make sure the batteries aren't getting rained on. Other points of problem can be if you have something metal above the batteries that can result in condensation of that salty mist from the air and then drip onto the battery. But one of the batteries that we have, our 4.9 kilowatt hour battery, is a wall mountable, and it's a NEMA 3R rated battery that can even be installed outdoors. So though the battery that you're seeing on the screen in front of you right now, that 5 battery, is not waterproof, our 4.98 kilowatt hour batteries are. And so that might be a good solution. So you can look into that, Fernando. But certainly if these are installed in an appropriate environment, they're great in tropical conditions. You know, we have many batteries on many islands. So
yeah, very true. And next time we're all together, I'll maybe grab a picture of that and we can take a look at what that looks like as a success. If you're here for NABCEP credits, email us training@simplifypower.com. Usually takes us about a day to issue the credits, and we'll go ahead and get them out to you. Please spell your full first and last name so that we get it, and we'll check the attendance records and go from there. So again, questions or comments, or you need your NABCEP certificate, training@simplifypower.com. Nathan, any last questions before we wrap up the hour?
No, that's it. I just want to thank everybody from joining us. Daniel, it's always a pleasure to walk through this with you. We love batteries and we love the questions you guys throw at us. And so if you come up with other questions we haven't answered, go ahead and use that same email, training@simplifypower.com. And Daniel and I will get back to you.
Thank you everyone for joining us, and thank you, Nathan, for being here today.